All right. So, you guys have highlighters? That's really going to help a whole lot today as we start talking about this, okay? It's not necessary because you would be here forever.
Exactly.
All right, so here's what we're going to do. I said use a number line, and then we're going to connect that to what Madison did the second part of class. But on a number line, what does it mean to have at least? 6 is the minimum. 6 is the least. So at the least means 6 or...
So in this case, 6 is 0? Or more.
Or more. Hang on. Yes, Avery?
I thought you were talking about the thing where you do like minus 4 plus.
No, not there yet. Not quite. All right, so $6. It says at least. So is $6 a possible amount? Exactly $6. Yeah, of course it is, right? So what we're going to do, we're going to put a circle around 6, and I'm going to color it in. And I'm going to give you some notes on this, so don't worry if this is like, oh, I don't get it. Which one, now, is it possible that she has 5 or 7?
7.
7, because we established that 6 was the least, the minimum, which is the best word to think of. So 7 is also possible. All right, to speak to Quentin's question, what about 650? $7.03. $100. So what we're going to have to do is represent all possibilities with shading. You won't learn to do that. What that looks like, Autumn, is this. But you won't learn that until Algebra 2. That's called an interval notation. An interval is a section of the number line. It represents a set of numbers. But what is the infinity part of our graphic? What makes you think infinity?
The arrow.
Yeah, the arrow. All right, so it couldn't be -5.
But that's not above 6.
Okay, so did I not let you finish? It could be any number above 6. What infinity means is not a number. Infinity is a... Somebody feeling this? Nope. Behavior.
Oh, okay, I get that.
So you can do infinity?
And beyond, there's no beyond infinity. Infinity means to increase forever. Therefore, negative infinity means to
Decrease forever.
yeah. See, that's a simple connection that I want you to hold on to. I don't know that you'll need it in Algebra 1, but you will need it in Algebra 2. Okay, so going over homework problems. There were a couple of number 30s that I saw people would really like for me to go over, so I want to do that before we talk about our lessons for today. So, which ones were they? Can you guys remind me what number 30s?
What number 30?
What lesson? Because I think I assigned it to 2 different lessons.
It was like 69.
69, 70. Okay, so 69, it's a similar triangles problem. All right, so what we're going to do, I'm going to draw these triangles. All right, so let me draw these. And I had a couple of questions about this. I've got 3 colors today, so yeah. So this is lesson 69, number 30. And we've got 2 triangles that are similar as indicated by the angles. Okay, and so sometimes I'll do little hash marks like this. I'll put 1 here, we'll put 2 there, and this one will be 3. And again, this is the one that's in your book, but I would recommend drawing these each time. And then we're given 2, 3, and y, and over here we've got 3x, and then 5.5. So the first thing I want to point out, I want to help make sure everybody understands what it means for 2 sides to correspond. The definition I was giving Anna was the shortest sides correspond. I want you to think about that. This is the shortest side in this triangle, not because I know what x is secretly, but because they connect these 2 angles, the 1 and the 2. So anytime you can establish that they're both definitely the shortest, or that they connect 2 congruent angles, then those sides correspond. Yes, Fisher?
The way you could figure, another way if you didn't know
if they were congruent, but you had the 2 and the 3, if you didn't know they were congruent and you had the 2 and the 3, you could either you would have to divide 2 by 3, if I'm correct. I don't know how to say that. And whatever the number is that means that you can either multiply any number on, if that they're all the same. If you had all the numbers and you did that, if they're all the same, then that means you could multiply any number on the smaller triangle by that number that you would get by dividing them. And the congruent side, that's what it would equal.
Corresponding side. So you're right, but what you do have to have the angles that tell you that the two triangles are similar. Otherwise, we can't establish that relationship. So the strategy you're talking about is called the scale factor. So once you establish what the scale factor is, that's like your magnifier. That's what a microscope does. Then you can multiply that and find your sides. Morning.
Let's go.
Okay. All right. So, sorry, I said that in my teacher voice. I didn't mean to. So, instead of using the scale factor argument that Fisher gave, here's what we're going to do. Is everybody clear on why I highlighted the sides that I did in the color scheme that I did? The oranges correspond. The pinks correspond. The yellows correspond. So, what I can do, I can write the ratio of the oranges. So 2 to 3. And then I can set that equal to another ratio of common colors. So I can either do 3 to x, or I can do y to 5.5. Now, the order of those, does that matter? Could I have flipped these and left the 2/3? No. Because I went little to big, I have to go little to big across the board.
So if you wanted to change them, you would have to flip them all and make
Yes.
it like 3 seconds?
Yes. So, I've got 3 pieces here. We can only work one side at a time, or pick 2, any 2, with a variable, okay? So I'm going to do this one first. 2 times x equals 3 times 3. So I have 2x equals 9. So x has to equal 4.5, or 4.5. So this becomes 4.5. Okay, now I can work the other side. So if we cross multiply here, 2 times 5.5, what's that? Okay, 11 equals, and then 3 times y. 3y. So we'll get y equals 11/3, or 3 2/3.
Could you leave them as a decimal?
3.6 repeating?
Yeah.
Yep. So, again, the color coding is super helpful. I would recommend doing that if you struggle with that, okay? Helping you identify what sides correspond. Questions? Can you use colors on your quiz? Absolutely. Okay, absolutely. I would highly recommend it, to be honest. I think that's why I put it in the recommended supply list for the beginning of the year, okay? It had a lot of stuff, including glue sticks, but... All right, so do I need to go over lesson 70, number 30? That's the same thing. It's the same thing, all right? So, let me draw the triangles. It's exactly the same type of question, okay? So you're drawing your triangles. B, 2, 3.5. Oh, I can see why this one would cause problems. Because they turned one of the triangles. It's all turned. Alright, so we can't do anything until we figure out which sides correspond. And the only way we're going to do that is to use the angle information that they gave us. So that's 1, this one's 3, this one is 2. And then over here, this one is the 1. Then we have the double hash and the triple here. So this triangle is kind of turned compared to this one. So A and 2 do not correspond. The way we're going to have to do that, if I highlight the 2, I want to take note of what angles it connects, right? Because those angles have numerical measurements attached to them, right? For example, this could be 70 and this could be like 95. Doesn't matter what numerical attachment they have, but rather that angle and that angle are the same. So what I want you to do, if it's connecting the third hash to the first hash, then that's all I've got to do over here. Now, let's do another one. So 1 to 2. So this is connecting one hash to 2. So I'm going to highlight the one that connects one hash to 2. It's that side. So the B and the 10 2/3 correspond. And of course, by the process of elimination, I have this. Okay? I'm also going to do one other thing here. I'm going to put D, E, and F at the vertices of these triangles. And we'll put G, H, and J at these for a simple clarification at the end. But before we do that, let's write our proportion to help us solve. So we can only solve for one variable at a time. So who can help me set up the proportion? What's the fraction that has numbers? 5 over 2. All right, so Autumn did big over little that time. Everybody catch that? And that's okay. 5 over 2, but notice they're both yellow. So 5 over 2, I've got to make sure I do big over little all the way across. So what's another big over little?
A over 2?
No.
Oh.
A over
3.5.
Yes. 3.5. You're good. It's important to make sure you get that right. Sorry. Oh.
What does that mean?
Nice of you to call me back. All right, so that's related to my other job. How do we solve this?
Other job.
Yeah.
What's your other job?
I'm an apprentice electrician.
Oh, cool.
So I got to work for a few years to get my license. What do we do to solve these? Cross multiply, right? So I've got 2a equals
5 times whatever.
5 times 3.5. 17.5. So we're going to get that a equals 8 3/4. Remember, I'm letting you use these.
I have that exact calculator.
Or Bar McKenna. Steal it.
All right. 8 3/4. All right, I need the other one. So Nathaniel, can you give me the other proportion that will help me solve for B?
So, 2 over 5.
All right, he can switch it up all he wants. That's fine, as long as the other side is also little over big.
Okay. Would it be 10 2/3 over B?
Is that little over big? So switch it up. B over 10 2/3. Okay, make sure you keep your order consistent. So in this one, we went little over big. Remember, 1/2 and 2 over 1 are not the same. Okay, so we're going to cross multiply again. We'll get 5b equals
21 1/3.
21 1/3. 2 times 2/3. Yeah, that's 4/3. Okay. 21 1/3, and then we got to divide that by 5. So we'll employ our friend here. 21 1/3. How many should I do? Okay, I can't do that. I'll just do a lot of them.
Can you write the repeating line on this?
I don't know if you can or not, but it doesn't want to do that. So that is actually a fraction too. Let's see, that would be what, 32 thirds. 64 thirds divided by 5, 64 15ths. Same answer. Okay. I'm good with this if you guys want to write 4.26 repeating. And if you go back up, the reason I really like these calculators...
Isn't that 4.26666667? Isn't that just 4 2/3?
No, that's 4.6 repeating.
If
That was without the 2.
line in the answer, that means there must be one in the calculator somewhere.
No, it doesn't.
Yes, it does.
No, it doesn't. The calculator people do not have an obligation to do exactly what the math tells them to do.
Yeah, but still, they wrote one like what you wrote. It's not fair.
You mean if the calculator, why can't the calculator do one? I mean, it could technically, but it requires the user to do the correct math, which was
Well, it
10 and
was-
2/3 is
the
32
calculator
thirds
wrote
times
a
5.
line by itself, which means you have to be able to type it.
It does?
Yes, because it wouldn't be fair. Because it's unfair to the calculator.
Just because you could do repeating decimal on like paper doesn't mean you have to do repeating decimal forever until you.
I kind of like where they're going because they don't let you do all the shortcuts that you think are fair. All right, so let's take a quick look at lesson 71. Did I get questions answered for similar triangles? Are you going to get highlighters to help you? If you don't need them, that's fine. I would recommend 3.
How many of these are going to be on the table?
At least one.
Okay. How about 60 billion? How many semesters?
1.
Is it a quiz or a test?
Wait, is that
Quiz. No.
And have you taken a test this quarter?
No. I haven't had a test. So we will have a test also. All right, lesson 71. All right, guys, give me 5 minutes and I will finish lesson 71. So roots and powers of fractions. So I'm going to write 2 properties. I'm going to write them in a really weird way, and then I'll write the simple way, okay? Luke, I think that's an honorable endeavor for you to figure out how to add that functionality to the calculator, to be able to put repeating.
I'm not a calculator maker.
Well, you could be. So, powers means exponents, right?
I'm pretty sure, yeah.
So, here's what we're going to do. We're going to write A over B, because that's a fraction, and then I'm going to do something weird. I'm going to put, what letter do you want to use for an exponent? E? Is E okay? Or do you want to use N?
N.
Okay.
N. Yeah.
What about
Yeah.
N?
What a great way to end the conversation. So,
I just say that just so you could do that.
I did not. It just kind of comes to me, okay? All right. So, what am I raising to the nth power? A over B. So check it out. This is how you simplify this, guys. A to the n over B to the n. That's it.
That's not even simple. You have to write more.
Okay, well, hang on a minute. I'm going to show you how it's simpler. Because let's say we had an example. Let's say we had to do 2/5 to the 3rd power. So what that means we're going to do is 2 to the 3rd over 5 to the 3rd. And if you remember what exponent means, it tells you how many times to multiply that base. So we're going to get 8 out of 125. It'll focus in a minute. Just give it a second. Okay, maybe it will. There. All right. Let me let you catch up. Come on and muster. So, Avery, can you see all right? You want to move up here? It's okay. Maybe we need a new setup anyway for the class.
Please don't.
Yes.
All the other teachers keep moving the tables around, and I hate it.
You guys like the consistency?
Yes.
Yes.
I say we get rid of the tables and all sit on a circle on the floor. I like
Yeah,
that. I
that's
like how
even
you
better.
had it every
All right. Anyway. Well, that would be an option too, Nathaniel. So, Autumn, have I proven how it does make it simpler? That you just, it basically shows you the incremental steps. What does this mean? This. And we're able to compute that with or without a calculator, okay?
Number is it's not really simple. It's
Huh?
the right.
What's a simpler mode of travel? Walking or an electric vehicle?
Walking. Electric vehicle because it doesn't pollute the environment.
I said simpler, not,
I mean walking.
yeah. But you have to take more steps than you do if you ride in the car, right?
That's simpler.
All right, so I want to teach you a real quick lesson that's going to apply to your whole life. In any problem that you deal with, you're going to have the opportunity to choose something that's a fast solution, a correct solution, and an easy solution. But You, listen, listen. You can only pick 2 of those at any given time. All right, now stop and think about what I just said. You can only pick 2 of these options.
Correct and fast.
Yeah,
Correct and fast will not be easy.
That's fine. If it's fast, it shouldn't be that hard.
Correct and easy.
Now, what you guys are saying is this is a really good reason to learn complex mathematics.
If it's correct
Because
and
if I
easy,
know the hard stuff,
forever.
it'll be fast and it'll be correct.
What if it's fast and easy and it is
It's
correct?
probably not correct.
What if it is correct?
Generally not.
What if it's
So like kindergarten math fast and easy is correct.
This is not for kindergarten. This is for your future.
What if it's like
Again, you guys are just trying to make me look like it's, which is an exception. But think about it, okay? If it's correct and it's easy, it's going to take you a little while. Now, listen. Listen, I'm going to give my example, and then I'll finish our lesson for today, okay? Here's your task before I write the rest of these notes, okay? Okay? Find the sum of all numbers, all whole numbers, sorry, let me make it easier,
numbers?
from 1 to 100.
What?
All right, now let's say, suppose this was your problem. Okay, quiet. All the numbers from 1 to 100, all the whole numbers. I want you to find out how much they add up to.
1,000. That's easy.
Okay, what is it?
It's just going to take a long time.
Ah, wait a minute. What? It's easy. It'll just take a long time. So what you're saying is it just won't be fast.
Yeah.
But you can get it right, and it'll be easy. It'll just take you a long time.
Yes.
1 plus 2 plus 3 plus 4. Now, that is completely true. But if you knew more complex mathematics that were not easy, you could get it correct in a fast way. It would just be hard. All
Because if you know how to do it, it'll just be a lot easier.
right, no.
Tell us how to do it hard and fast.
You have to learn it. There's still a challenge up front, right?
So we need to make sure of all that.
What you have to do, here, I'll tell you, if you want to know the not so easy part,
Tell me.
but before I get there, my other way to describe this analogy is that you can either take a bicycle or a rocket to a location. They'll both get you there. One will just be slower. So they're making an airplane then, okay.
I don't think you can travel on a rocket.
One's more
The
expensive.
bicycle is longer and faster too.
Yeah.
Wile E. Coyote does. All right.
Wile E.
Huh?
Coyote.
So the bicycle will probably be faster because you have to like.
Okay.
Oh, that's
Too real for me. All right, so have I made my point yet that you can only pick 2?
yeah. You've made.
All right, so the answer is 5,050.
What? How'd you know that?
All right, because I knew some stuff that's not easy. That's how I knew that.
How does that equal 5,050?
5,050. All right, let me ask you something. What number is in the middle of all the numbers between 1 and 100?
50.
No,
50.697.
that's closer, but no.
50.5.
That's it. So what we'll do is take the average of all 100 numbers, which is
Wait a minute.
50.5, and multiply it times 100. 50.5 times 100 is 5,050. Well, no, it's not, but why did I do it?
Because it's fast and easy.
Yeah.
No. I told you what it was. The hard part is understanding that you can do that.
So if you just know to do it.
No, if you just, how many things are like that? You just know. That's why we got married. I just knew.
Every day.
I don't know why I stick my lips out when I talk that way, but that's what happens.
It only applies to math here.
So, the hard part, 2, 3, skip a little bit, 97, 98, 99, 100. In the middle, if you cut these in half, is 50.5 because you have 50 numbers to the left, 50 down to 1. You have 50 numbers to the right. No, that's why I'm doing it this way. So 50.5 is in the middle of what? 2 simple numbers.
Why is it 50.5 and not 50?
Because 1 through 50 is 50 numbers.
It doesn't include 0.
51 through 100 is 50 numbers.
Oh, okay.
So it's in between 50 and 51.
Oh, so 50's not really 50 between the other.
No, 50.5 is.
That's weird.
50 is.
50 is if you include 0. But I said 1 to 100, didn't I? All right. Nonetheless, back on track. My 5 minutes of challenge is up. You can pick 2 at any time. Very rarely will you be able to do all 3. Now, no more conversation on that. Fast, correct, or easy doesn't matter. I just want you to get it right. So,
You can't do all those. It's 1 plus 1.
this is simpler. Now, the other side of this is, what if we have to take the nth root of a over b? Have you learned anything from what happened here? You see, what is the relationship between the nth power and the nth root? I heard it. Somebody said it. I heard it. What's the relationship between the nth power and the nth root?
They're opposite operations.
They're opposite operations. Guys in the back, pay attention so you can get to this part. Otherwise, this one might not be possible. All right. So, how do you think we're going to simplify it, Autumn? If you look at what happened here. If you look at what happened here.
So you just have to put them all together separately?
Yes, that's it. We're going to calculate them separately, right? You might, if I ask you a strange question, like, what's the cube root of 8/27? What I'm telling you is that you can find the cube root of 8 and the cube root of 27 and write them one over the other.
2 9.
2/3. So, here's what we want to make sure we get. That's it. So the example here, let's say I ask you to find the square root of 144 over 9. What that allows me to do is find the square root of 144. Now the 2 wouldn't be written. I'm sorry, I shouldn't have done that. 144, and then divide it by the square root of 9. So what's the square root of 144? 12. What's the square root of 9? Oh, it's 4. Wait a minute. What must 144 over 9 be equal to if I find the square root of it and I got 4?
16.
So 144 divided by 9 is 16. Remember that. Okay? That's how I do things fast. It's not because I'm doing things fast. I just remember it. So, maybe we should do one more of those. Or do you guys feel like you're good with that? I think you're probably okay with that. So the last thing for today, solving inequalities, it's related to Jen's money. Okay, so we're not going to be solving any of these yet. We're just going to be representing inequalities on a number line. Okay, so the shading part, some of you said you'd already done this section on Delta Math. Fantastic.
Oh yeah, I just know.
But the reason we have to learn how to represent this, the reason we have to learn how to represent this is because not every equation will have one answer. It will rather have a... Guys, why are you talking? What am I talking about?
Math. Not everything will have one answer.
We'll have a section of the number line to represent the answer. Okay, so what we want to make sure we get here, and again, if you have a highlighter, that would make it easier for you to see what's going on because you can't tell what these colors say. But you have kind of a key of what these symbols are. That's greater than, that's less than. And if you have trouble, study it. But if you still have trouble, this one looks more like an L. So, it's kind of like less, I don't know, whatever you got to do to remember it, okay? I don't remember what this is. It's probably a video that goes over the same content. But this is what you're used to doing. A dot, that's it. Here, x is 3. It's not 3.1. It's not 0. Can't be anything else. Okay, so that's equal to. That's absolute. There's no fluctuation. Here, in the first example, it says x can be any number greater than 3, but not including 3. So, if you read this, how do you read this? X is greater than 3. Does not mean x can be 3. So we left an open circle here, okay? Whenever you see an open circle, that means it does not include the value, okay? Does not include 3. Now, to contrast that, also, here's what I want to make sure. I put the shading over here, okay? So if you have a highlighter or something, or maybe a red pen, make sure you see that the shading is to the right because the number 4 is to the right and it's greater than 3. Okay? 4, 5, 27, 3,500, 2.58. Again, any number that is greater than 3. Now here, this is different. So what I want to make sure I emphasize here is this is a closed circle. This is a closed circle. So that means x can be any number 3 or greater. So again, I want to make sure you see and understand that it includes the 3, which is why it's closed. Okay? We can go on with any number greater than or equal to 3. So, let me highlight here to make sure you see that there is shading in all of these. Okay? But again, make sure you pick up on the difference. It's really difficult to tell that that's an open circle, isn't it? Can you guys tell that the first one is open?
Yes.
Yes.
Let me just make it really obvious. Okay? All right. So, what do you think this one means? X is less than 3. So, we're going to put any number less than 3. And it does not include 3 here. So we can put 2.9 repeating. We can put 2.6. We can put 1, 0, negative 87. Okay? So, is this going to be open or closed? This is open. It's open when it doesn't include that value. I'm going to call that a boundary value, by the way. Okay? Okay, so this one is actually shaded the opposite direction. So you can kind of treat this like an arrow. It means we're going to shade this way. Okay? And it's going to be open. Last one. X is less than or equal to 3. Any number less than or equal. So I want to make sure just to keep the same language. It includes 3. So it's going to be closed. So 3, 2.99, 0, negative 17. Again, anything that is to the left of the 3. So we're going to shade to the left here. So these are called number line graphs for inequalities. Eventually we will solve these instead of equations. Okay, so instead of like x plus 5 equals 6, we're going to write x plus 5 is greater than 6. We'll have to represent that there's more than one number as a solution. So that's why these are necessary.
This is the one part I don't have done on the delta math.
All right. Do you feel like you can do it now?
Yes.
Any questions before 8th graders leave? All right.